As I said, you have part 3 of chapter 1. It's about logic, and logic is important in computer science, especially in writing programs, in conditional programs. It's just for yourself to read this, okay? Now you have proposition. We should know what's a proposition and what's not, okay? Proposition or statements are the same. What's a proposition and what's not a proposition? Here we say it is a declarative statement, sentence that's either true or false. That statement is either true or false. Question statement is not a proposition. Okay. Here, each proposition is either true or false. There is no proposition which is both true and false. Okay. For example, here we say 4 is less than 3. We say 4 is less than 3. Is it true or false? It's false, because 4 is greater than 3. It's not less than 3. That's why we say this is false. And you have 7 is an odd integer. 7 is an odd integer. Of course, that's true. So we say that statement is true. Washington, D.C. is the capital of the United States. It's also true. Okay. We say a proposition is a declarative sentence that's either true or false. Okay. Now we have some examples which are not propositions. We say, why do we study mathematics? The answer is not true or false. Okay. So that's why we say this is not a proposition, it's a question statement. Okay. Study logic. Someone tells someone else, study logic. It is not a proposition also, it's a command actually. What's your name? It's a question also. It's not a statement, or it's not a proposition. Here, quiet please. That's also asking for someone to do something. Okay. These two are commands, and these two are questions. That's why these are not propositions. These 4 statements, these 4 are not sentences. I mean, these 4 sentences are not propositions. The first one and third one, because they are questions. It's not a statement. They are not statements. The second and fourth one, these 2 are commands. That's why we say these are not propositions. Here you have an example. The temperature on the surface of the planet Venus is 800 Fahrenheit degree. It is 800 Fahrenheit degree. It's either true or false. Someone say this information. It's either true or false. So that's why you see this is a proposition. And here the second one, we say the sun will come out tomorrow. It may not come out because it would be cloudy. Okay. If sunny, of course, it comes out. So we say it's either true or false. That's why we say these 2 are propositions. Both are propositions. Now we have some operations that join propositions. The first one is conjunction. Conjunction means and. In English, it means and. And mathematically, its symbol is a caret. This means and. Okay. It's like 8 in Kurdish. Okay. This means and. Here, when we join two statements by and, the result is true in only one case, if both are true. That means if you have, let's say, P to be a statement and Q to be another statement. It's true. Which time? Both must be true, then the result is true. I mean, both statements must true, then the result is true. Okay. For example, if you say 3 is, let me write down symbolically. 3 bigger than 4. Okay. 7 is odd. Look, let's say this is P and this is Q. We have these two statements. Both are propositions. The answer for the first one is false, is it? It's false because 3 is not greater than 4. But the second one is true. That means false if we join them, or if we combine these two statements by conjunctions, by and, it's false and true. What's the result? The result is false. Why? Because when you join two statements by and, both statements must be true, then the result is true. Okay. If any of these is false or both are false, then the result is false. Okay. We will take some examples about this. So here we say the result is true only when both participating propositions are true. Now you have truth table. This table is called truth table. If we have two propositions, if you have two different propositions, we say, let's say we name the first one to be P, the second to be Q. How do we write down these true, false, true, false? These are given. And how do we know these? We say for the first one, a half of statements must be true. And the second half is false. Okay. The first half of statements is true, and the second half is false. Here we have two statements, so we must have if we have two propositions, P and Q, we must have 4 statements. Okay, we must have 4 statements. Here, the first 2 are true and the second 2 are false. And for the second one, true, false, true, false, true, false, like that. Okay, true, false, true, false. Okay, for the second one, we order them true, false, true. We start from true, then true, false, like that. Here, this one, we should find this column. We should find this column. How? Here, we join these two statements by and operator or by conjunction. That's it. This is the operator. Look, they are combined by and. True and true is true. True and false, as we talked about, it's false. Because at least one of them is false. False and true, it's still false. False and false, of course, it's false. So here, in this truth table that we made for conjunctions, we have only one case which is true. In the case if both are true, in the case if both statements are true, the result is true. يرجع بكل باسه كمان conjunction بمعنى and do رصة do دستواجه بيك أو بستين باشا do statement شكاتك ريزلتك أنجامك راستك true بيت أجر هاتو هردو دستواجه راست اگر هر دو دسته واژه راست بون انجامکشی راست دەبێت. لێرە ئەم تیبڵی کە هەمانە پێوترێت truth table. ئەم تیبڵە بەعام هەمووی پێ ئەوترێت truth table. truth table بۆ conjunction ئێمە ئەگەر هاتوو دوو propositionمان هەبوو، دوو گۆڕاومان هەبوو p و q، ئەو کاتە دین چیەکەین؟ ئەو کاتە دین دوو بەتوانی ژمارەی گۆڕاوەکان، ئەمە p و q مان هەیە، دوو بەتوانی چەنە؟ دوو، واتە چوار ستیتمنتمان هەیە، چوار ستیتمنتمان هەیە. چۆن ریزیانەکەین؟ بۆ کۆڵۆمی یەکەم بۆ p دێن چیەکەین؟ نیوەیان ترووە بن، نیوەیان فۆڵسە. بۆ ئەوەی دووەمیان نیوەی نیوەکەی دادەین. ئێستا من نیوەمەدان ناوە ترو، نیوەمەدان ناوە ترو، ئەمە ئەیە بە دوو بەشەوە ترو فۆڵس، ئەمیش بە هەمان شێوە، ئەمە هەمووی فۆڵسە، ئەیە بەچی ترو فۆڵس. بەم شێوە دانن کەمانەمان دانا. ئەنجا دێن چیەکەین؟ بزانین ئەو کۆنجەکشنی کە بڵێن ئەو ئۆپەرێتەرێکە هەمان چێ کۆنجەکشنە. لێرە p and q مان هەیە، وتمان لە ئەندا تەنها یەک حاڵەت ترووە، ئەگە هەردووکیان ترو، ئەگە هەردووکیان ترو بوو ئەنجا ترو دەبچێت، کەواتە ترو ترو ترووە. بۆ شێوەیە ئەگە لانی کەمێک دانیان فۆڵس بوو ئەنجامەکەی فۆڵس دەرەچێت. So this is about conjunction. Now I have some examples. Here we have two statements or two propositions. It says 2 is an even integer. That's true, is it? 3 is an odd number. Of course, it's true also. When you say p and q, it means true and true. And the result is true. So the result here is true. And also, if we write down both together, we say 2 is an even integer, and if we write down this in words, if we write down this in words, we say 2 is an even integer, and 3 is an odd number, and 3 is an odd number. The result is true because the first one is true and the second is true. So the result is true. Here you have two statements which are joined by conjunction and both are true. So the result is true also. It says 2 divides 4. Can you divide 4 by 2? Yes. 2 divides 6. Can you divide 6 by 2? Yes. So both are true. Here we have two statements, both are true. Here, these are two propositions. If we combine them together, it becomes a compound proposition. You say p and q. P is true, q is true, and they are combined by and. And the result is true. And also we can express in these words, we can say 2 divides both 4 and 6. That's the same as the above one. Both have the same meaning. In the first one, it says 2 divides 4 and 2 divides 6. That's the same as to say 2 divides both 6 and 4. Okay. Now I have two propositions. 5 is an integer. That's true. 5 is not an odd integer. It's false. Because it's an odd integer actually. It's an odd integer. And here it says 5 is not an odd integer. That's why it's false. We have two statements. The first is true, the second is false. If we write down together, it is true and this is false. So the result is false because at least one of them is false. And you can also write down as 5 is an integer, but 5 is not an odd integer. Okay, this is true and this is false. Here, the most important thing here is to know, is this statement true or false? And then when you join them by the operator, here you have conjunction, the result is true or false. That's all here. Now you have disjunction. Disjunction means or. In English, it means or. And the symbol, the mathematical symbol or logical symbol for O is that V shape. This is the symbol for O. It's a V shape. We say two statements, or we say the result is true when if at least one of the statements is true. If you have only one true, that's true, the result. Okay, that means in only one time, in only one case, we get false. If both statements are false, if both are false, false or false, the result is false. In other cases, if you have at least one true, the result is true. Okay, that means true and false, false and true. True or false, false or true, true or true. These three cases are true. This is the truth table for disjunction. Disjunction means or. So the truth table here, as I said before, the first half is true and the second half is false. And for the second column, we have true, false, true, false. Then we're going to find these by using these two. The first two columns. From the first two columns, we get the third one. True or true, as you see, they are joined by or. True or true is true. True or false, look, here you have at least one true. That means the result is true. False or true, here also we have one true statement. So the result is true. False or false, both statements are false. So the result is false. In the previous one, in conjunction, look, in conjunction, we get only one true when if both statements are true. But in disjunction, we get only one false when both statements are false. Okay. So here you have two statements. P as 2 is an integer. That's true. That's true that 2 is an integer. 3 is greater than 5. Is it true? No, it's false. So if we join these by or, the first one is true or false. How about the result? The result is true, of course. It's true. Why? Because at least we have one true statement. The second one, we have 1 plus 1 is 3. This is false because 1 plus 1 is not 3, it's 2. The second one is a decade is 10 years. Yes, that's true. So you have false or true, false or true, and the result is true. Here it says 3 is an even integer. It's false because 3 is odd, it's not even. 3 is an odd integer. This is true. False or true? False or true is true. And that's about disjunction. Now you have negation. Negation of a statement. Yeah, we are going to take the negation for the statement. For example, if P is true, then the negation of P is false. Can happy لا true يبقى false or false يبقى true. negation وقتها بيشوانا كلمة. Here we use these symbols for negation. Okay, we usually use this one, but in the other references, if you see these, this means negation. So here for negation of P, we write down this. That means it's negation of P. Look, here you have only one state, one proposition, one symbol. That means we have 2 to the power 1 statements, which is 2. Here we must have 2 statements. True, false, that's all. Negation of true is false. Negation of false is true. Okay, we just negate the statements. So you get false for negating of true, and the negation of false is true. It's only changing its value. Here you have a statement says 2 is positive. If we take its negation, what you get? You say 2 is not a positive number. 2 is not positive. ليه بيتشوانا كوري؟ على دو جماري كي مجبر. أجا بيتشوانا كوري بيوم دو جماري كي مجبني. Okay. So the negation of P is 2 is not positive. Here we have some exercise about disjunction, conjunction, and negation. These are for yourselves. I'm going to do this one, okay? Look, it says P and R are true, and Q is false. How about the result of each of these two statements? Of these two, I mean, compound statements. Look, it says P is true. So you take the negation of true, and Q is false, or R is false. Let's see what's the result. The result is either true or false. Okay. First, we must take the negation of true. Negation of true is false, and in this bracket we have false or true. So the second R is true. Sorry, this one is true. False or true, it is true because at least one of them is true. That means we have false and true. The result is false. Why? Because in conjunction, this conjunction, لأندا أبي هردو كان true أنجام كان true. برام بير داني كان false. فهذا أنجام كان شيء بيت false. Oh, for the second one, we have R and negation Q. Look, R is true, and negation Q is false. Or P is true, or R is true. Just write their values. They are true or false. Here, first we must change this false to true because here we have negation. We get true and true, or true or true. Look, here, true and true is true. Okay, here you have O. True or true is so true. So the result is true. So this statement is true, but this one is false. Change this to be. Okay. Now you have conditional propositions. If, then. You say if P, then Q. That means if P happens, then Q also. Here, when we combine two statements and join them by conditional propositions, in only one case it's false. In only one case it's false. If the first one is true and the second is false. If it's from true to false, the result is false. In all the other cases, it's true. Yep. If the first one is true and the second is false, say if T, if P, then Q. If P is true and Q is false, the result is false. In only this case, the result is false. In all the other cases, the result is true. Okay? And this is symbolically if P then Q. Okay? P then Q. You see that. Look, the truth table for conditional propositions, the truth table, as you have two variables, that means you have 2 to the power 2 statements, which is 4 statements. You have 4 statements. Half of them is true, and the second half is false. And for the second column, we say we make this 2 parts and this 2 parts. True, false, like that. So now we have true, then true. Look, both are true, so the result is true. We say in only one case it's false. If the first one is true and the second is false. In only this case, it's false. Look, true, then false. So the result is false. As you see, the first one is true and the second is false. But here we have false, then true. It's true. It's from false to true. It's not from true to false. So it is true. False to false is also true. ليه انت هاي ليه حالتها false اگر هاتو يكم true بو دون false كواتا ordinary statement كان اساسا نابل we say P then Q is not equivalent to Q then P. وحتى ناتو عن جيجي statement كان بوري ordinary statement كان اساسا ليه لا بيو بو كيو بروين يا equivalent نية لو كا لكيو بو كيو بروين جواز بون منا دو statement مهيا قريما دو statement مهيا على P on 2 is positive 2 is odd second I'm going to cube if this is Q and the above one is P. Here we say P then Q. What about P then Q? Is it true or false? How about Q then P? Okay. Look, first we should know each of the statements either true or false. Okay. The first one is true and the second is false. That means P is true and Q is false. So for the first one, we say true, then false. And the result is, it's true, it's false, sorry, it's false. But for the second one, it is false, then true. Since P is true and Q is false, so it's false to true, it is true. Look, we get 2 different results. That's why we say P then Q doesn't equal to, it's not the same as to say Q then P. Okay? These are not equivalent. We have 2 statements here. P, it says today is Sunday. Today is Sunday. So it's false. For now, it's false. Q, I will go for a walk. Look, we have conditional. We have conditional statements. Okay. We say if today is Sunday, then I will go for a walk. If today is Sunday, then I'll go for a walk. That's how to join P and Q. So today is not Sunday, so it's false. Even the person who said that go for a walk or not, let's say it's not, he doesn't go to walk. So false, then false. The result is true. That's how to join these two statements. Look, I get a bonus. This for P. I will buy a new car. To combine these two by conditional statement, we say P then Q. That means if P happens, then Q. Then Q happens also. Look, if I get a bonus, then I will buy a new car. Okay. If I get bonus, then I will buy a new car. Let's say he or she got the bonus. Then she bought the car. So true then true is true. So what if she doesn't buy the car? The result is false. Okay. So here we have these two cases. Look, x over 2 is an integer. X is an even integer. Okay, look, we say if x over 2 is an integer, that means if x is divisible by 2, then x is an even integer. Of course, that's true. Both, if the first one is true, the second is true also. If the first is false, the second is false also. Yeah, in this case, look, if x to be 4, 4 could be divided by 2. Okay, S4 is an even integer. Yes. سكت شوار تواني دابش من هي بسردوها بله. كواتا أو جمارة على أجر X تواني دابش من هو بسردوها معناه يوا X شيا جمارة كي جوتا. بالتأكيد واحد. أجر كم راس بيت دو مش الراس. أجر كم تواني دابش من هو بسردوها. Yes. The value of X. Look, we just imagine if it's even or not even. Okay, if it's even, it could be divided by 2. It's divisible by 2. We just imagine if it's not given. It's not given. Yeah, yeah. Of course, yeah. Look, it says if x over 2 is an integer. أجر x ده integer bit أو x جوتا أو رصيها مراسة all true. Yeah. The first is true and the second is true. Both together are true. That means true, then true. We just need it for here. Okay. We just need it for this case. True, then true. So the result is true also. Okay, but here it's not question, it's condition. It's condition on x. We say if x is divisible by 2, then x is an even integer. That means if the first condition is satisfied, then the second also. على أجر جماركم هبيت وأنا هبيت تواني دابشون هي وسردوا أو جمارية جوتا أما راسا قصي كم نيرة هل أوي هماشتا Okay. Yes, it could be. Yeah. Look. Yep. Yes, of course. Look. Can we divide? Look, can we divide 5 by 2 without having any, reminder? We cannot. So it's not divisible by 2. 5 is not divisible by 2. We must only take the even ones. Okay? We must only take the even ones. That's why we say if x is divisible by 2, of course x is an even integer. Look, 6 could be divided by 2 without reminder. Okay, 3. For example, 7 couldn't be divided by 2 because 3.5, you have reminder. That's not true. So for only the even ones, these two statements are true. So if the first is true, the second is also true, and the result is true. Now I have biconditional statements. Proposition. We say let P and Q be propositions, then P if and only if Q. When we join two propositions by biconditional, we say P if and only if Q. We get true if both have the same situation. I mean, both are true or both are false. Then it's true. So true if and only if true is true. Then false if and only if false is false. So it's true. Must be true. All the other cases are false. It's biconditional statements. Look, they are combined by this symbol. And this symbol is called biconditional. We say the result is true when both statements have the same value. I mean, both are true or both are false. In only that case, in only those two cases, the result is true. Here you have the truth table for it. Look, here you have column P, column Q, then column of P if and only if Q. Yeah, it reads P if and only if Q. P if and only, sorry, true if and only if true is true. As I said, both are the same. False if and only if false is true. No. In these two cases, we get true. True if and only if false, and false if and only if true. They have different values. One of them is true and the other is false. That's why the result is false. Okay. So in conditional statement, we say if the first is true and the second is false, in only that case you get false. All the others are true. Let's get P then Q man here. P if and only if Q man. لما تشكي حالتك false يك حالتي false معها. The true بروا false and Java كي false. برام ليرة دو حالة true معها دو حالة false معها. True كان كمان true bit false bit and Java كي تشيا true. In these two cases we get true. So let's take a break, okay, for 10 minutes. We said that in the biconditional, if both statements are true or both statements are false, the result is true. In other cases, the result is false. Here, you say, my program will compile. It has no syntax error. We say, my program will compile if and only if it has no syntax error. Of course, if the program is compiled, it must have no syntax error. If this is true, that's true also. True if and only if true is false. So if the program will not compile, that means it's false. Okay, let me use another color. If this is false, how about this one? Of course, it has syntax error. It's false. Sorry, it's true, the result. The result for the first one is true. True if and only if true is true. And also false if and only if false is true. So in both cases, if the program compile means it has no errors. So both are true. So if the program will not compile means there is some syntax. That's why the program doesn't compile. Here we say x is divisible by 3. X is divisible by 9. We say x is divisible by 3, x is divisible by 9. That means if we combine them by this operator, means by conditional, we say p if and only if q. That means you get x is divisible by 3 if and only if x is divisible by 9. We say x is divisible by 3 if and only if x is divisible by 9. Of course, if a number is divisible by 9 and it's divisible by 3 also, and conversely also, except 3, because 3 is divisible by 3, but it doesn't divisible by 9. It's not divisible by 9, except 3. All the other numbers true. So here is the same as the previous one. We can say it's true. Okay. And here, even we can give an example that it's not true. Look, this is true. And if we take 3 is divisible by 3, but it's not divisible by 9 because 3 over 9 equals 1/3. So it's not true. True if and only if false is false, because we said in biconditional both statements must true or false, then we get true. We say if capital Q and capital R are made up the propositions P1, P2 up to Pn. If each one have n statements or propositions, we say Q and R are logically equivalent. These two are logically equivalent if they got the same results on the truth table. In the truth table, we must get the same result for both. As you see here, we have Q, capital Q, which is P then Q. This represents Q. And negation Q, then negation P represents R. It says show that Q and R are equivalent. Look, for equivalent, we just write down three lines. It's like that. Yeah, we use this for equivalence. We say P and Q are equivalent. We must show that P and Q are equivalent. That means we must show that P then Q is equivalent to negation Q then negation P. Okay? You must show that this statement equals to that statement in the truth table. You must get the same value for each on their columns in the truth table. We use truth table to show that two statements are equivalent or not. Here we have only P and Q. That means we have two variables. We have P and Q. It means we have two variables. So 2 to the power number of variables here is 2, which that means we have 4 statements. We have 4 statements. For P, true, true, false, false. This for P. Always write down P as the first column. The second column is Q. And if you have R, write down it in the third column. P, true, true, false, false. Look, we just do this one. Here we have only P and Q. And for Q is true, false, true, false. Then we should find each of these. We should find this and that. If they both the same, means they are equivalent. If not, if there is any difference between them, we say they are not equivalent. Let's check. For P then Q, we say for P then Q, in only one case it's false. If the first one is true and the second one is false. True, true is true. True, false is false. False, true, true, false, false, true. So we have only one case which is false, which is if the first one is true and the second is false. So this is P then Q. That means P then Q is true, false, true, true. This is P then Q. And for negation Q then negation P, we must get the same. We must get the same order. It must be true, false, true, true. Let's check. First, it's easier to find negation P and negation Q. Negation P, negation Q. Okay? What's the negation P? P is true, true, false, false. Becomes false, false, true, true. Is it? Then for Q, false, true, false, true. And we combine these together by conditional set. By conditional. By if then. It goes from negation Q to negation P. That means it goes from here to here. Here to here. It's like that. Now, false, then false. Look, from here it goes to there. That means this is the first one. Okay? This is the first one. Because it goes from negation Q to negation. Okay? So false, then false is true. True, then false. Look, the first one is true, the second is false, so it's false. This is true, and this is true. Look, we get true, false, true, true. You even can write down only the table which is given. Yeah. Look, we got true, false, true, true. As you see, we got the same. And the same order for each. That means these two statements are equivalent. So if we have, if here, in negation Q, then negation P, if we get true, true, false, true. How about this one? If these two are true, this is false, that's true. Look, it's false, but here is true. It's true, here is false. So these two are not equal. We must get the same with the same order for each. So this is, at that case, they are not equivalent. But here now, As you see, we got one false and others are all true. And the false are in both in the second one. That's why you say these two statements are equivalent. تنها بكره هنا خشي truth table. لين شيكين statement هاي عشان statement هاي PQ معناه PQ negation هاي حسابنا هذا PQ حسابه دو variable معناه PQ كاتبه شن element معناه بيت شن statement معناه بيت علين هميشه دو بتواني جماري variable كان أبي statement معناه بيت دو بتواني جماري variable كان جماري variable كان دو بتواني دو واتشوار أبي تشوار statement معناه بيت بو variable يكم نيو بنيو true نيو false بو variable دوم true false انجا اواني كا دوسينو اما انا دوس راوند اما خود بيزاني بيسي اما انا شو دوسينو بهوي تشيو بهوي دو كولوم يكم وا اتن چيوان دوسيو p then q ما دوسيو و دوات نيجيشن q then نيجيشن ما دوسيو سيركي ام دوانا هر دو كان هماش من دسكوتو دير هر دو که ماش پاندس کدو که وقت چین دو ستیتمنت ام دو compound ستیتمنت ما یک ام دو هم دو آنی که همان چین equivalent. It says show that negation of p then q is equivalent to p and negation q. Let's make the truth table. Okay. Here we have how many variables do we have? 2. That means we must have 4 statements. So P, Q, P is true, false, false. Always write down P as the first column. Okay, the second column is Q. Then true, false. Okay, and also here we have P then Q, P then Q, and we have also negation of this, which is negation of P then Q. It's easier to do all, to expand all, and this for the left hand side. This is the result of the left hand side. And for the right hand side, we must first find negation Q, and then here we have no negation Q before. That means we must find negation Q. And then P and negation Q. This is the right hand side. These two must equivalent. Okay? The left hand side is negation of P then Q. And in the right hand side, you have P and negation Q. Look, for the first one, for this one, it's P then Q. It goes from P to Q. True then true is true. True then false is false. False then true is true. False then false is true. So that's for the first one. And then we are going to take the negation for these results. If we take the negation for these results, we get negation of P then Q. So we get false, true, false, false. We just took the negation of these. We got those. This is the left hand side. And for the right hand side, we must get the same result. Here we have negation Q. What's Q? Q is here. True, false, true, false. We are going to take the negation for this. True, false becomes false, true, false, true. False, true, false, true. And then we are going to combine this with this. Look, P and negation Q. Do it step by step, you will not take mistake. Look, true and false is false. True and true. Look, the second one is here is true, and the second here is true. It's true. False, false is false. false, true is false. Look, are these two equivalent? I mean this and this one. Are these two equivalent? Yes. These two are equivalent. As you see, the first one is false in both, the second is true in both, and the last two ones are false in both. So these two are equivalent. So if you see the word equivalent or this symbol, you should use the truth table for proving it. Now I have precedence of logical connectivists. Here, the highest, which is starts from negation and then to the lowest, which is if and only. And to order these, it's easier to start from this first brackets. First work on the brackets, then negation and or then and if and only if. It's work on them by this order. Here, first we should work on brackets. Okay, construct the truth table for this one. We just make the truth table. We just make the truth table for this statement, this compound statement. This compound statement must be on the right column, last column. I mean, here we have two variables which are P and Q. That means you must have four statements. So you have P, Q. For P, it is true, true, false, false. For Q, it's true, false, true, false. Then, what we do, we're going to work on each bracket. For this one, P or Q. And also we have Q, then P. First, let's find the negation of this. And you have negation of P or Q. Okay, and you also have P and Q and P. It's the same actually, but I'm going to write down the same as it's written there. And the last one, look, we expand it. We expand step by step. Look, first, second layer, we have 12 sheep kino, chicken. So that P or Q man. Do chi man negation bomorjila. And layer chi man P and Q man. Amatama hadula hazira. But if then take your basinta. So we say negation of P or Q. Then Q and P. That's all. This is the last column. For the first one, P or Q. For this one, P or Q. If only one of them is true, the result is true. Is it? So true or true is true. True or false is true. False or true is true. False or false is false. Okay. It's for the first one. It's for P or Q. And for negation of this one, we just take the negation of these results. Okay? We just take the negation of these results. True becomes false. True is false. True becomes false. And false becomes true. That's all. It's for the left-hand side. And for the right-hand side of this, I mean, for this one, for this operator or disconnected. Here we have Q and P. We have Q and P. We are gonna combine these two, Q and P, by AND, by conjunction operator. Q and P. Q, true and true is true. In only one case, in only one case we get true. If both are true, for and, in only one case you get true. If both statements are true. Here you have true and true is true. False and true is false. True and false is false. False and false is false. Okay. Now we combine these two by if then. We say we get only one case which is false. If the first is true and the second is false, let's check. Which one is that case? This one. So this is false. And all the others are true because we have only that case which is false. So other cases are true. We get true, 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 and the last one is false. So this is the truth table for this compound statement. That's all together is the truth table. Now we have an exercise here. Now this exercise, you should do it by yourselves. It's just about constructing the truth table for each of these compound statements. Now we have logic and set theory. We say X doesn't belong to A, and only if the negation of X belongs to A. Okay, these two statements are actually the same. We say A is a subset of B, if and only if for all X in A, X to be in B. That means if we take any element from A, we can find that element in B. So it means A is a subset of B. And if A to be an element in A intersection B, it must be in both sets. So you say X is in A and X is in B. It must be in both. For the union, we say when X to be an element in A union B, we say if and only if X in A or X in B. That's either in A or B or in both. Okay. We say if X to be in A difference B, that means X is in A but not in B. Say if and only if X is in A and X is not in B. If X to be an element of A delta B, it means X is in A and X is not in B, or X is in B and X is not in A. That means X is in A minus B union B minus A. Okay, when you say X is in A delta B, it means X is in A minus B or X in or B minus A, sorry. We say when we say A is so X is in A complement, as we said, A prime means A complement. It means the negation of X to be in A. The negation of X to be in A means X is not in A. If X is not in A, means it's in its complement. If X belongs to power of A, we say X belongs to power of A, and only if X is a subset of A. X is a subset of A. Here it's just to know how these operations on sets are combined by using if and only if by conditional statements. Now you have Venn diagrams. We say we can use Venn diagrams for union, intersection, difference of two or more sets. Okay, as you see here, this is the intersection of all sets because it's common in all sets. But this is this one. That's the intersection of A and B, because here we have elements in only A and B. And the union is the set of all of them. Okay, all together is the union, and the intersection is only the common ones between two or more sets. Now you have logic and sets. Look, here you say tautology. Tautology means the result is true, all true. Look, if we do this one, the result, I mean the final column, is all true. All the statements are true in the final column. The result is true. That means tautology. And here we have set operation identity. We say P or Q, and only if Q or P, it means A union B equals B union A. It's only changed two sets. And here we have those operations that you did on the statements. It's only just for yourself to read it, okay? It means here there is a similarity between logic and sets. There's a similarity between them. It means that. It's the same as the previous one. It's also logic and sets. Here you have tautology and set operation identity. It's only for yourself to read it, okay? Now we have some theorems for logic or some operation for logic. Here you have idempotent. Idempotent means if you have a set with itself, just combining a set with itself. Look, P and P, P or P. In both cases, we get P. In both cases, we get P. Here, we have the identity element, with respect to and the also. We have the identity element, I mean, for and or also, the identity one is the set itself. As you see, if we connect a proposition with the self by or and, in both cases we get the proposition itself. As you see here, we have P and P, P with itself. That is T and T, true and true, true and true is true, false and false is false. And for O, say true or true is true, false or false is false. In both cases, you get the same. As you see, in both, all the columns are the same. All are true and all are false. That means every connect a proposition with the self by or and statements, we get the same. We get the same result. And you have double negation. If you have double negation on a proposition, we get the proposition itself. For example, we say 2 is even. If we take the negation of this, we get 2 is not even. This is P, this is negation. If we take another negation for this one, here we say 2 is not even. If we take a negation, we get 2 is even. Okay? So the negation of negation cancel each other. These two negation cancel each other. If they must after each other. Okay? If they are after each other. But here in this case, if you have let's say negation of P or negation Q. Here we cannot cancel out these two. You must enter this to the bracket, then cancel out the one which we give to negation Q. Now we have commutative law. Commutative law is if you have P and Q and P are the same. If you have P and Q, for example, true and false equals to, it's equivalent to false and true, and equals to, it equals to false. In both cases, you get false. Even for O, you say P, so true or false is equivalent to false or true, equals to true. So it's commutative وقت algor. كرداري algor ما هي لأور والآن لأور والآن كرداري algor ما هي أتو أنجي كانيان بكورين. Now you have associative law. يا سيكتر بستن. إما قد بيتو سيك إن ما نهبت. قد بيتو سيك variable ما نهبت. ستاقا يكم دون بلان بمرجب همان كردار بيكو بسراب بهمان كردار بيكو بسراب هادو كان هالآن بيت اوكي ليش هادو كان آن بيت اگه هادو كي اور بيت بهمان شي هادو كي اور كواتا اگه هادو كان اگه هر سي variable كان بهمان كردار بيكو بسرابن او كاتا يكم دوما كي سرتا دوم سيما كي سرتا كشنية لو أنا كسي سرتام دوانا بكات دوات اللي قلوات لو أنا كسي كتير يكمل دوم بكات دوات اللي قلوات إيش كشنية كان دوداني أنا كي سرتا كشنية okay even for O it's the same, it's associative law. Now I have distributive law. If you have PO, look, if you have different operators connectivists, you say PO, Q then R, it's equivalent to P or Q, P, look, P or Q and P or R. Okay? So you get P or Q and P or R. And also for P and Q or R, we can say P and Q or P and R. So that's it. And also we have absorption laws. We say P and P or Q. If we have the same variable, if we have the same variable, we say P or P and P or Q. It equals to P itself. It's equivalent to P itself. Even if we have P or P and Q, P, so it's P itself. These both are P. It's equivalent to P. Okay. So if you see something like this, P and P or Q, oh, it should be Q, not sorry, it's Q, it should be Q. It's Q. In these two cases, you can just write down P, okay? In both cases, you get P. Even if you tried by the truth table, you just get the same as column P. That means you get true, true, false, false. You have distributive law. Look, as you see here, we have distributive law. We are going to make the truth table for distributive law. P or Q and R is equivalent to P or Q and P or R. But here, as you see, we have 8 variables, 8 statements. Why? Because we have 3 variables. We have 3 variables, which are P, Q, and R. That means we have three variables. And as I said, if we have n variables, we must have 2 to the power n statements. Here we have three variables. That means we must have 2 to the power 3 statements, which is 8. And for the first column, we are going to write down half of these statements true, then the second half is false. And for the second one, here we make it 2 parts. A half of the true ones become half of it is true, and the other half is false. And for this one is also these two true, these two false. And for the last one, we must have true, false, true, false, true, false up to n. Okay. So that's how to create these 3 columns. You must do these 3 by yourselves. And then what we do, we are going to use these 3 columns to get these. Okay, it's easier to find Q and R first. Okay, let's find Q and R first. What's Q and R? Q and R, it's true. In only one case you get true. If both are true, this is false. I'm just gonna write down between them. Okay, this is Q and R. This is false. This is false. This is true because both are true. This is false. False, false. Now, what we do, we are gonna combine this and this by OR operator. Look, this is Q and R, and that's P. We are gonna connect them by disjunction. Sorry, conjunction. Here we have true or true. What's true? True or false? Sorry, that's not that false. This one is true. True or false is true. True or false is true. False or true is still true. False or false is false. False, 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 false. You get this? For what? This is for P or Q and R. How about the last one? It's just for proving that P or Q and R is equivalent to this one. Okay. Now it's easier to find P or Q and P or R, then combine them by AND. Okay. What's P or Q? P or Q is just combining these two by OR. So you get true, 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 false, false. We just get 2 false. Here for this one, we just get 2 false in the last. Okay, the last 2 ones are false, others are true. And for P or R, the P or R, P or R, these two. True, 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 false, true, false. Okay, so you get only 2 false. This one and this one. So for this one, for P or Q, what we get? We get true, 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 false, false. But for P or Q, P or R, sorry, we get true, 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 false, true, false. You get this. Now, if you combine these two by AND, what we get? True and true is true. True and true is true. True, true, true. False, false, false. As you see, we go down, which is done there. We got the same as which is done there. So it's easier to do step by step. Okay? Do step by step, you will not get mistake. Okay? So do you have any question about this which we talked about? Okay. We have one more or two more. We have two more slides. We are gonna finish these two and okay. Sorry. I didn't know that the time is up. Okay, it's enough for this lecture. We will have another lecture today. Okay. If you have any question, you can ask.